All right, welcome back, ladies and gentlemen. I'm happy to introduce our first Space Force participant for the talks and I think any innovation summit. So welcome to Capt. Myles Spetsios, who is going to talk to us about swarm satellites.
Hi, everyone. I'm Captain Myles Spetsios, United States Space Force. I'm here to talk to you about my paper I did on swarm satellites, different approach the Space Force can take to satellites on orbit. So just going to jump right into it. During the presentation, I'm going to talk about what the current operating environment is, what we're doing in space, and then some of the challenges or threats that are to us, and then my ideas to fix some of them. So right now, the current space operating environment is we utilize space for almost all of our military operations in the modern era. Anytime you go out, we have remote sensing operations happening. Those remote sensing operations are providing the warfighter information, whether it's terrain, whether it's weather. Just think of how important some of those aspects are to the modern day fighter. It's providing your ISR, your intelligence, surveillance, and reconnaissance. It's providing your communications, and many times command and control goes over those communications. Just the amount of information being given, it is a vital piece of the fight in today's battlefield. So it's important. Space is important.
Yeah.
And that's why we need to be thinking about it and look at how we're doing it. So today, or rather in 2018, according to the World Atlas, we had about 123 DoD satellites on orbit. And through those DoD satellites is how we do all of our space operations. So 123, 2018, we'll probably have a few more right now, but I imagine not that many more. So right now, those satellites aren't safe. On 11 January 2007, China actually conducted an anti-satellite missile test. They successfully destroyed one of their own satellites. Russia has done this multiple times. Most recently, just a couple months ago, on 15 November 2021, they also successfully shot down another one of their satellites. It's not the first time they've done this. The reason that our adversaries would do this, China and Russia, they want to show the world they possess this capability. They possess the technology to destroy their own satellites. If they possess the technology to destroy their own satellites, it's very reasonable that they possess the technology to target and destroy our satellites. As I mentioned, with all of our operations going through the space domain, maybe not all of them, but it's very important to the warfighter. Our military operations could be not in a great state if they decide to start shooting at our space assets. So another thing to consider is just how expensive these satellites are. According to the Government Accountability Office, a single space unit, when I say unit, I mean a single satellite, costs anywhere from $500 million to $3 billion for the DoD. You take that into account that we have large contracts out there, such as the Advanced Extremely High Frequency contract. It was awarded to Lockheed Martin. It was to put 6 secured communication satellites into orbit. That contract was about $15.5 billion for them to execute. Of note, it also costs about $100 million or more dollars to put a satellite into orbit, one of these monstrosities. They're very big satellites. They're very capable. To give you an idea of how big they are, one of these satellites weighed over 6,000 kilograms. That's about the size of 5 cars. So just in size and weight, they're very heavy, they're very capable, but they're also very big targets that are just floating up there. There's 6 of these satellites, $15.5 million program. To put that number into perspective, the Space Force's budget for 2022 was $17 billion. So if you were to put 6 missiles into space in the right locations and orbits, you could sink the entire cost of a branch of military for the United States for 6 missiles. Wow. So it's expensive. There's a lot of stuff up there. They're big targets, though. And that's what we kind of need to start moving away from, is putting these huge targets up in space. Yes, they have a lot of cool capabilities, but they're big targets, and putting all of your ducks in one basket may not be the best way to go. So what I'm proposing is we identify how to move things into cube satellites. So the concept of a cube satellite, if you look on the screen, it's these small satellites that are somewhat modular in nature. basic definition is it's a cube that's 10 centimeters by 10 by 10 centimeters. And their design, you can either have a single piece. They weigh generally about 1.3 kilograms, and they're pretty easy to make, and they're pretty cheap to put up into orbit. You're not spending 100 million plus. Generally, right now with modern day spacelift, it costs about $4,000 per kilogram to put something into orbit.
Okay.
Multiply that by 6,000 and then look at 1.3. Realistically, a one cube satellite won't have all of your answers in one, but because of their modular design, you can either stack them. So if you see on your screen the example, they're modular, they can go together. This graphic shows up to 12, but they can actually go up to 24 or 36 even, depending on your need and how much capability you need on one satellite.
Okay.
But then the idea is you have a distributed environment now. So instead of having all of your eggs in one basket, you have a bunch of baskets all with one eggs. Maybe this satellite over here focuses on a bit of communication. This one focuses on remote sensing. This one is specifically a relay just to get all that information back. We're not talking about hundreds of satellites here. We're talking about thousands, if not tens of thousands of satellites. And they're small. If you lose one, it's survivable. There's redundancy built into the system because of how many satellites you have up on orbit. The cost will also be cheaper. You'll be able to build them a lot quicker. So in the example of the AEHF contract, the Advanced Extremely High Frequency, that was those 6 military satellites. That took us 21 years to finish that program, get them all up on orbit.
Wow.
We don't have time to spend 21 years putting satellites into orbit anymore. If something happens, we need to be able to throw more satellites up as fast as possible. Even a 5-year lead time is going to be too long if we're operating without some of these capabilities that we rely heavily upon. So if we have the ability to have smaller satellites up, by nature, smaller satellites are going to be harder to target than a larger satellite. But we need to be able to put them up quicker. So how can we put satellites up quicker? We have to be able to manufacture them faster. One of the ways we can do it, it's actually been proven that you can 3D print these cube satellites now.
Wow.
They all use the same sort of chassis, and you can modify them how you need it, whether they need to go together or you need more. But because they use the same basic modular design, you can manufacture them fairly quickly.
Okay.
You're not necessarily making as many as like a car factory where you're making hundreds of thousands of cars. If you're only going to be making 10, 20, 30,000 satellites a year, you might not have a full-fledged factory, but it's very easy to stand up a 3D printing warehouse that's just popping these suckers out.
Wow.
It takes about 19 hours to print a 10 by 10 by 10 centimeter area cubed. And that's with the modern day additive manufacturing. So essentially that's manufacturing with advanced alloys and metals. As you can imagine, the space environment is very hostile. So you do need special compounds and components that can operate up there. There's a lot of challenges, but you can use advanced 3D printing technology to address some of these issues.
Okay.
It's not going to address all of them. You're still going to have other factors to take into consideration, but it will collapse your manufacturing time substantially. For example, just think of all of the machining and the welding that needs to take place to put these components together. A lot of that is removed from the equation because the machine is doing it all in one for you.
Okay.
So utilizing modern day technologies, essentially I'm proposing that we move away from these large satellites, go into these smaller satellites, these distributed technology systems, and that's going to be one way that we can make our satellites more survivable in the future fights and allow us to have more resilient systems if something were to happen up in orbit. That's really all I have right now. That's a quick overview. Are there any questions?
We'll open it up to the virtual or live audience if there are any questions that you have. Looks like we've got one. Gunny?
Thank you, sir. The question I had is, you referred to like scalability, 3D printing as a way to make these things presumably like custom sized on the ground. Is there any plan that you know of or can talk about that would make it possible to fit these things together in orbit, like an orbiting, arm or satellite that could fit two of them together, or is that just some sci-fi stuff that I'm imagining? Over.
Great question. So they actually are looking at ways to 3D print in orbit. One of the advantages to doing that in orbit is compounds react differently. With gravity and the atmosphere on Earth, materials and alloys operate differently than if they were in space. Just think of, a thin layer of air you might have between metals first on the ground versus in orbit. So they are looking at ways to actually send 3D printing stations up into space and see how things react. It's a widening area of study right now, but a little bit outside the scope of what I'm proposing. Yes, they are looking into it, but I don't know exactly what their plans are. I know there are some scientists researching it now, though.
Because obviously commercial technology is starting to do this with what is it, the Starlink series is coming out, and others that are trying to do similar capabilities. Is this something that we would be able to partner with, or just easily replicate ourselves in order to do just by the U.S. government, or would it be even cheaper to partner with commercial vendors to try and support this?
So I'd say you want a little bit of both. You want to be able to have your in-house capabilities to build these, and then if you run into a situation where, let's say somebody detonates a nuke into space, that's actually going to knock out all of your satellites in low Earth orbit. It's going to charge the Vanderbilt belts up there, and essentially the radiation doesn't degrade. It has no matter to run into that will degrade it. It will degrade slowly over time, but not before it essentially takes out all of your satellites.
Wow.
So in a big deal scenario like that, partnering with industry is fantastic because, hey, if they have the right 3D printer, we can then leverage them to assist us in reprinting these satellites to get more of them up in orbit faster.
So repopulate. Okay.
We would want to keep some of the technology in-house. I imagine there are some advanced components that we're using, but for the most part, industry will be able to assist us, and we can leverage them if needed to help supplement our own production.
Okay. Next question then on, not necessarily on the actual satellite technology, but on the launcher technology. So we've seen commercial industry also get on that with the reusable rockets, making it easier and cheaper to get them up. I've also seen other articles talking about some of the centrifugal launchers and some of the other capabilities. Do we see that getting to the point where maybe expeditionary being able to launch any of these, or is that still something that's going to require a fairly large footprint and investment in order to be able to do that?
So when you say expeditionary, are you talking about forces on the ground?
Potentially. Obviously, this is a little bit further out since I'm a science fiction fan. I like to think a little bit deeper, but as we see some of this stuff and we talk about being able to build more resilient capabilities, right? Not necessarily just launch from a particular location or a fixed location that can be targetable and needs to be protected. But to your point about building resilience where it's harder to target, we confuse the targeting environment that people have to go after in order to have a significant degradation against our capabilities. Is that something that we may be able to see down the line, or is that a little too science fiction at this point?
So some piece of it may be a little too science fiction. However, you did hit an important piece on the head. Because these satellites are smaller, you can use smaller rockets if needed to put them into orbit. Mm-hmm. To your point, if one of our launch sites were targeted and destroyed, we can still launch other satellites through smaller launch sites. Right now, there are companies out there that are focusing solely on how do we put CubeSats into orbit, that question. They're not looking to put large satellites, the 6,000 kilogram satellites in orbit. They're only focused on the smaller ones. Because they're focused on the smaller ones, they're using smaller rockets. It's a little more accessible of a technology for some newer companies. And it's going to allow them and us to put these assets into orbit more easily, more economically. The other piece for some of the centrifugal and, the tactical actions, I think the challenge there, just, thinking about it, is you have to be very wary of what orbits you put satellites in. You don't want them colliding with stuff that's already up in orbit. And you also want to be aware of where, your space debris may be. There's a lot of folks who do track this, but just having someone pop something in real quick to launch a satellite, that might be a little bit further into the future.
A little dangerous. Okay.
Or maybe when, we're exploring other celestial bodies, but might be a little in the future still.
Good. Any questions?
Are there any identified limitations at this point, or if you look at the capability suite that additional larger satellites provide, that these cube satellites could not simply just requirements to take advantage of miniaturization of existing technology that's either works or already exists. Like, is there any point that's already been identified when cube satellites will not be able to replicating existing capability?
I don't know if there's anything specifically that they can't do. I know there's areas that will be more challenging. Think of satellites that are farther away from the Earth, like in your geostationary orbits. Instead of being a couple hundred miles, they're tens of thousands of miles away. That's going to have more power requirements, and your cube satellites may or may not be able to fulfill that. That doesn't mean you can't necessarily send up individual cube satellites and link them up somehow to produce enough signal to replicate these capabilities, but there will be some technological challenges to fully replicate stuff of that nature. Some of those bigger sensing capabilities, the large antennas we have in space that are doing listening or just transmitting information.
For those who may not have heard it in a virtual audience, the question was, is there a point at which, is there a point at which cube satellites will not be able to replicate some of the capabilities in the larger satellites? That was the question. Ladies and gentlemen, that concludes day one of the calendar year, academic year 2022 Innovation Summit by the Brew Krulak Center for Innovation and Future Warfare. Captain Spetsios, thank you very much for coming on and being our inaugural Space Force member. It's been a pleasure. I appreciate it, sir.
Thank you very much for having me, sir. I appreciate it.
Education is what's important. Training, preparation for the expected. Education, preparation for the unexpected.